Hello all, welcome to my channel. I am starting a new series of blogs or videos that we will have in upcoming days, and these are aimed at, let's say, someone is trying to build a data platform or an ML platform and any kind of platform in the data and AI space. What I am trying to do with these blog series is to provide alternatives. So, for example, let's say if someone comes as of now today and asks that, okay, I am trying to build a data platform. So, for example, definitely the choices will be okay for event streaming. Why not use Kafka? For let's say for distributed computation, use Spark, and let's say for orchestration, we use Airflow. For in-memory cache, let's say use Redis. So these have these systems, the names that I have taken like Spark, Kafka, Redis, Airflow, these have become kind of a synonym to the verb itself rather than being a noun. So why I say it has they have become verb is, for example, let's say when we say orchestrate, we need an orchestrator. It doesn't have to be always an Airflow, because Airflow is good at certain things. It is not good at certain other things. For example, Spark. So when we talk about compute engine in case of big data, we also definitely believe that okay, Spark will be something which helps us. But Spark is not the only choice. It has a lot of advantages, but it has associated cost as well, and it has associated overheads as well. For example, to maintain in Spark cluster, you need people to maintain that Spark cluster. Or let's say if you are using managed services, let's say you are using EMR in AWS or Google's data proc. So you pay an extra money. You are paying for the license of the managed service. So those are things that we have to understand that okay, instead of directly saying that okay, we go ahead with one particular engine. We should be weighing the pros and cons and then deciding upon which engine, for example, we should be choosing. For example, let's say in this case itself, choosing the right data processing engine for modern data platform. So it's not only that we can only rely on Spark. For example, we can even choose Pandas, Trino, DuckDB, Apache DataFusion, Daft, Dask, Hive, or even Polar. So there are different use cases. Why each of them have a different strategy? Why each of the engine excels at certain workloads? So let's go ahead and see how and why I believe these can be an alternative to Spark. Is that first of all there are two types of engines in this. So there are one single engine and there are multiple engines. So when we say single node engines, what does it mean? That it doesn't have a distributed scheduler and orchestrator which can distribute the work and then combine back and give us the result. So it always is a single engine, means it requires to be run on a particular host where this is installed, and it will only work on the data set that fits in that particular node's memory. So for example, Pandas, Modin or Ponder or Polars, DataFusion, DuckDB. These are all single node engines. um, we can make them distributed as well. So I will talk about those in coming videos, but or upcoming timestamps of this video as well. So these are single node ones. Then we have the distributed ones like Hive, Presto, Spark, Dask, Daft. So these are distributed engines that we can leverage and work. But the point is, when we say data processing on modern data platforms, let's say, it doesn't have to be a distributed engine. So when we need a distributed engine, when we have something data that needs to be processed across systems or which cannot fit in one single system's memory. For example, let's say, can we process 100 GB data on one single machine? We might, because although we might not have 100 GB RAM on that particular system, but still we can process if we are not loading everything at once in the memory. So there are systems which are and also once if the memory is there in that system, and if we are able to read that much of data, it will always be faster than a distributed system, because in distributed system there are a lot of serialization deserialization involved in terms of data moving from one system to another system, although it might be partitioned and then processed in parallel, but there is certain cost associated to that. So there are scenarios where single node engines will perform better compared to what we will be achieving with multi-node systems. So there was a report published by folks from Google's BigQuery team and Amazon Redshift's usage report, which says that the 90% of the queries that were happening on BigQuery as well as on Amazon Redshift were processing less than 1 TB of data, and 80% of the queries are even less than 100 GB. So when we say we are processing less than 100 GB of data, then we don't need a distributed engine to process that 100 GB. So that can be processed on a single machine itself, for example, and that's one uh, what you call logical division of data set processing engines has been arrived. It's not that something it is there. It is just for a reference. We should not take this okay that 1 TB below will do that. I just this is just an assumption based on certain numbers published in the report. So what it says is that let's say we want to process less than 10 GB of data. Pandas is very good at doing that. It can process in single machine itself. Let's say we have 100 GB of data. Then Polars, which is a Rust version of, I will say, Pandas, or not Pandas, but it is something similar. Then we have DataFusion, which can process 1 TB of data at a single node engines, although it's a single node engine. Then if we have one more than 1 TB of data, then DuckDB in a distributed fashion, or Hive, Trino, Spark. So these see where is the boundary coming for Spark. So if we have let's say more than 100 TB of terabyte of data that we are trying to process, then we should be definitely looking at Spark or Dask. But if we are processing smaller and smaller data, there is no need for that. Even the Hive engine was working well for distributed data. Still, less than, let's say, I will say around 5 to 6 TB of data can be processed. Trino, which is again an uh, rewrite of, I think, Presto, not rewrite, as a fork of Presto. So that can be another solution. So based on these, we should be deciding on which engine to choose, like based on certain heuristics. We don't have to just settle down for one particular engine and then work. So to just give you an example, I believe there is a company called Graybeam, which what it is trying to do is that it can listen to all the engines that are there, and based on the query patterns that you have, it will choose the right engine for you. So you don't have to decide on that, okay, I want to run this workload on Spark, I want to run this workload on Snowflake, or I want to run this workload on, let's say, single node engine like DuckDB. That gray beam does automatically for you. So maybe I'm not sure about what strategy they use, but the one thing that I can think of is it's all based on the metadata. So let's say if you have a data hub catalog, or let's say any catalog engine with the stats of the tables maintained, like for example you have max min rows, number of tables, number of partitions for each table, the partition sizes, or maximum and minimum ranges in those partitions. So if we have those information, and let's say you have a SQL statement that you put in your Graybeam UI, what they might be doing is they might be parsing and creating a plan and then mapping that plan while they do the logical resolution that, okay, what does this column mean? They also get the stats of that table from the data, so from the data catalog, and then they decide, okay, that this query will not going to touch more than, let's say, 100 GB of data. Then there is no point of running it on a distributed engine. They can simply fire it up to a DuckDB engine, which reads the data, processes, and returns back the requests very fast. Let's say if it is going above and beyond the, let's say, the 10 TB mark, then it can go to Spark or Snowflake or any distributed engine. So what they might be doing is they might be generating plan for different engines and see the cost, and based on the cost they will choose the right engine. So I think that's a very good approach that we can do. And I believe if someone is building a data platform, this feature should be there, that you should not be the data platform should offer multiple compute options, and based on the right tool for the right data set, we should decide the which engine to use. So this is a rough ballpark, a rough guidance that, okay, if the local data, if we can process on locally a small data 10 GB, pandas and polars will work. Okay, polars will outperform because it is written in Rust and it has less Python overhead. Let's say local data, we are processing locally and we have small data, let's say 100 GB, then polars will definitely work, but DataFusion and DuckDB will outperform polars. Let's say if we have local plus medium size data, but let's say around 1 TB. So then in that case, DuckDB or DataFusion both have almost similar performance, but DataFusion is a new product, and it has not all the mapping of a PySpark, or certain functions will not be available in that sense. So DuckDB is battle tested, more reliable, so we can use that. Uh, so this says that DuckDB can be as efficient as Dask or Spark on a single big VM. So if we have single big VM versus small VMs which are running Spark, single uh, VM DuckDB will be better, or at least at the same time. So let's say if we are working with cloud, and we have 1 terabyte to 10 terabyte of data, so Dask or DuckDB both can work. And if we have large VMs with capability of handling to process terabytes of data, DuckDB will outperform anything. Presto or even Athena serverless is available that can solve the problem, but will be slow compared to DuckDB. But still, they do the job. It's not, we don't have to use Spark at that time. Let's say we are doing cloud at very large scale, then Dask or Spark can come into picture and then process it. Dask will often outperform the Spark one, then means OSS ones. The reason for that is Dask has certain optimization done, which uh, uh, doesn't have those optimization in the Spark engine, because Spark still has a JVM overheads. But let's say if we combine Spark, a native engine, with DataFusion, that again can outperform Dask at times. So those are the options that we have, that we can use. And this picture simply says that the reason why these have things in common is they all are leveraging the arrow format. So if Parquet table is there, so each of the engine can read it in the same format. In memory representation will be same. So for example, it can be DuckDB, Daft, DataFusion, Polars, and that's how it makes more sense to use these things interchangeably. Or the example that I was showing of let's say gray beam. So let's say if we can do is we can have an representation at the arrow level, so all the engineers understand, and let's say we can have shared memory between them, so we can process certain things in DuckDB, and that will have the same in-memory representation which Daft consumes. So that can be also mix and match can happen. And this is how we read the different file systems, different ones using different engines. For example, this is how we read it in Parquet, the same thing being read in DuckDB, same thing being read in Polars, Daft, and DataFusion. So these are certain things. So this is one first introductory video where I have given alternatives to Spark while when it comes to building a data platform. Similarly, I will be creating more and more videos, like we will have alternatives to OpenSearch, we will have alternatives to Kafka, we will see alternatives to Flink. So do watch this space, subscribe to the channel so that whenever I upload that video, you can see that in quick time. If you like this, do share and spread the word. Have a nice day. Bye.